So students, in the previous class, we did up to question number 63. Now we have to go to question number 64. Here is question number 64. According to question number 64, y equal to x into x minus 3 whole square strictly increases for the x in the interval. So it is about increasing. So take the derivative of x into x minus 3 whole square. So using chain rule, dy by dx is something square, x square. Derivative is 2 into x. But the derivative of x into x minus 3, you have to use product rule. Derivative of x is 1 into x minus 3 plus x into derivative of x minus 3 is 1. So this is the derivative which you set it equal to 0. So 2 into x minus 3 into 2x minus 3 equal to 0. The values of x you get as turning points are x equal to 0, 3 and 3 by 2. So on the number line, take 0, 3 by 2 and 3. Go from minus infinity to infinity, making intervals, 4 intervals. In each interval, randomly you have to pick up numbers, like here minus 1, here 1, here 2, and here 4. And you have to put it in the derivative dy by dx. That is 2x into x minus 3 into 2x minus 3. When you put x equal to minus 1, 2 is positive, x minus 1 negative, minus 1 minus 3 negative, minus 2 minus 3 negative. So the derivative dy by dx is negative here. When you put x equal to 1, 2 is positive, x equal to 1 is positive, 1 minus 3 negative, 2 minus 3 negative. So the derivative is positive. When you put x equal to 2, 2 is positive, x equal to 2 positive, 2 minus 3 negative, 4 minus 3 is positive. So the derivative is negative. When you put x equal to 4, 2 is positive, x equal to 4 is positive, 4 minus 3 is positive, 8 minus 3 is positive, so the derivative is positive. That means y is decreasing, increasing, decreasing, and increasing. The increasing intervals which they're asking for is 0 to 3 by 2 and 3 to infinity. 0 to 3 by 2 is there, 3 to infinity is not there. So you can go for option A. Next is 65. The set of all points for which the function x square into e power minus x increases. So find the derivative of the function using product rule. Derivative of x square is 2x into e power minus x plus x square into, when you have to find the derivative of e power minus x, use chain rule. E power x derivative is e power x, but the derivative of minus x is minus 1. So you have to make it equal to 0. Take out e power minus x common and x common. Left is 2 minus x equal to 0. So x is 0 and 2. These are the turning points. Take the number line, put 0 and 2, and from minus infinity to infinity, make 3 intervals. In each interval, you randomly pick up -1, 1, and 3 and put it in the derivative, that is x into 2 minus x by e power x. E power x will be always positive. When you put x as -1, x minus 1 negative, 2 plus 1 will be positive. So f prime is negative here. F dash is negative. When you put x as 1, x1 is positive. When x is 1, 2 minus 1 is positive. So f dash is positive. When you put x as 3, x3 is positive. 2 minus 3 is negative. So f dash is negative. That means f is decreasing, increasing, decreasing. So decreasing interval we need not see. We have to see increasing interval 0 to 2. That is option 2 is correct. Option D, not 2. Okay, next question. We completed 65. Now we'll go to 66. The function f of x is monotonically decreasing. So take the function cos x minus 2px. The derivative of the function cos x derivative is minus sin x. Minus 2p is a constant, x derivative is 1. So set it equal to 0. Sin x equal to minus 2p. But the function is decreasing. In the question itself, they said the function is decreasing. That means, what does it mean? Sin x plus 2p. Decreasing means f dash should be less than 0. Sin x plus 2p must be less than 0. That's the condition. Or sin x by 2 plus p should be less than 0. We will write here f dash minus sin x minus 2p must be less than 0. Or change the sign, sin x plus 2p must be greater than 0. We know that sin x will be always between -1 and 1. The range of sin x will be between -1 and 1. So sin x plus 2p, where it will be? Between -1 plus 2p and 1 plus 2p. But because sin x plus 2p has to be greater than 0, 1 plus 2p also must be greater than 0. 2p must be greater than -1. P must be greater than -1 by 2. So option B is correct. Next, we'll go to 67. The function kx cube minus 9x square plus 9x plus 3 is increasing. So you take the function kx cube minus 9x square plus 9x plus 3. Find the derivative of the function 3kx square minus 18x plus 9. Take 3 common, kx square minus 6x plus 3. Increasing means f dash should be greater than 0. 3 is already positive. So kx square minus 6x plus 3 has to be positive. As per the condition. Now the discriminant delta is b square minus 4ac. This will be less than 0 if k is greater than 0. And this will be greater than 0 if k is less than 0. So what you can say is 12k is greater than 36, k is greater than 3. Because in the options, they did not mention about k less than 0. That's why we are taking only this. K is greater than 3. Option C holds good. Next is 68. The equation has at least one root in the interval 0 to 1. So the function we are going to take here is x cube plus 2ax square plus bx in the interval 0 to 1. So that f dash x will be 3x square plus 4ax plus b. So we are talking about having 0 for this. The function which we have taken is a polynomial. It is differentiable and continuous in this interval. So f of 0 will be 0 and f of 1 is 1 plus 2a plus b. The derivative becoming 0 at least one time, slope becoming 0, horizontal tangent. That can happen if Rolle's theorem is satisfied. So according to Rolle's theorem, f of 0 must be equal to f of 1. 1 plus 2a plus b must be equal to 0. That means option B is correct. Next is 69. If the sides of a triangle ABC vary slightly in such a way that circumradius remains constant, circumradius R is constant. That is what they said. Then dA by cos A plus dB by cos B plus dC by cos C equal to what? So we have sine rule in triangles. A by 2 sine A equal to B by 2 sine B equal to C by 2 sine C equal to circumradius R. So we can say A is 2R sine A. B is 2R sine B. C is 2R sine C. And then dA derivative will be 2R. Sine A derivative is cos A dA. Derivative dB is 2R is a constant, cos B dB. Derivative of C is 2R is constant, cos C dC. Now dA by cos A plus dB by cos B plus dC by cos C is 2R cos A dA by cos A plus 2R cos B dB by cos B plus 2R cos C dC by cos C. Cos A, cos B and cos C will cancel. You'll have 2R dA plus 2R dB plus 2R dC. Taking 2R common, you'll have derivative of A, derivative of B plus derivative of C. You know that A plus B plus C angles is 180 degrees. Derivative of A plus derivative of B plus derivative of C is 0. So this answer also we will get 0. That means option C is correct. Next, question number 70. The equation e power x minus 1 plus x minus 2 equal to 0. How many roots? So clearly the equation is e power x minus 1 plus x minus 2. It will be 0 if x equal to 1 because e power 0 plus 1 minus 2 will be 0. So x equal to 1 is one of the roots. Now if you take f of x as e power x minus 1 plus x minus 2, when you are finding the root, we are saying that f of alpha, if it is 0, alpha will be the root. Already we got alpha as 1. Alpha equal to 1. But suppose if you take alpha greater than 1. For f alpha of 0, alpha greater than 1. That means f dash x. The derivative of, using chain rule, derivative of e power x is e power x. Derivative of x minus 1 is 1. Derivative of x is 1. So this is the derivative of f. So because we have alpha greater than 1, the interval is 1 comma alpha. Now in this interval, the derivative must be 0. At least once. That means e power x minus 1 should be minus 1. Which is not possible. E will be never negative. So no root. No other root we have. That means we have only x equal to 1. Only one real root, that is a. Next is 71. On the interval 0 to 1, the function takes maximum value. So we will take the function x power 25 into 1 minus x power 75. The derivative using product rule. X power 25 derivative is 25 x power 24, 1 minus x power 75. Plus x power 25 into, here for the derivative, you will use chain rule. That is x power 75 derivative is 75, 1 minus x power 74 into derivative of 1 minus x is minus 1. Now you have to set this one to 0. But before that, take 25 common, take x power 24 common, 1 minus x power 74 common. So left is 1 minus x. And then minus 3x equal to 0. So x is 0, x is 1. 1 minus 4x is 0 means x is 1 by 4. These are the turning points. 0, 1, 1 by 4. On the number line 0, 1 by 4, 1. But the interval taken is 0 to 1. So this interval only you break it into 2 intervals. Randomly you select. You can select 0.1. You can select 0.5 and put it in the derivative. What is the derivative? 25x power 24. 1 minus x power 74. And 1 minus 4x. If you put 0.1, 25 positive, 0.1, 0.1 power 24 positive, 1 minus 0.1 power 74 positive, 1 minus 0.4 positive. So f dash is positive. If you put 0.5, 25 positive, 0.5 power 24 is positive. One minus 0.5 is positive. 1 minus 2 negative. So f dash is negative. That means f is increasing, decreasing. But what they asked you about maximum value. Increasing means going up, decreasing going down. So here you have maximum value for the function. X equal to 1 by 4, at x equal to 1 by 4. At what point x equal to 1 by 4? Next, I will put 72. For a between pi and 2 pi, the critical point of the function you have to find. So the function is 1 by 3a sine a tan cube x plus sine a minus 1 into tan x plus root of a minus 2 by 8 minus a. When you find the derivative, 1 by 3 sine a is a constant. You use chain rule for x cube derivative is 3 tan square x. Derivative of tan is secant square x. Plus sine a minus 1 is a constant. Derivative of tan x is secant square x plus last term is constant again. So 3 and 3 will cancel, no denominator. You can take secant square x common. Left is sine a into tan square x plus sine a minus 1. And set it equal to 0. Of course, secant square x will never be 0. So sine a into tan square x plus sine a minus 1 has to be 0. Or I can write tan square x is 1 minus sine a by sine a. Now, since a is in the interval pi to 2 pi, in this sign is negative. In this interval, sign will be negative. One more thing is sine a will be always between minus 1 and 1. 1 minus sine a. Okay, next step is I will put minus sine a will be between 1 and minus 1. Or I can write minus sine a will be in between minus 1 and 1. Because the first signs has to flip. When you take minus, the signs has to flip. Now 1 minus sine a, add 1 between 0 and 2. So 1 minus sine a is positive. On the whole, 1 minus sine a is positive, but sine a will be negative. So we are getting tan square x as negative, which cannot happen. So no solution, no critical points. Option D is the correct answer. Next is 73. The difference between greatest and least values. Of the function, that is 73. So take the function f of x sine 2x minus x. Find the derivative using chain rule. Sine x derivative is cos 2x. 2x derivative is 2. X derivative is 1, which you set it equal to 0. Cos 2x is 1 by 2. We are taking in the interval minus pi by 2 to pi by 2. That means 2x will be pi by 3 and minus pi by 3. Or x will be pi by 6 and minus pi by 6. So you have to find f of minus pi by 2 endpoint, f of pi by 2 endpoint, f of pi by 6 endpoint, turning point. We got turning points. And f of minus pi by 6, another turning point. So sine of minus pi will be 0. And minus of minus pi by 2 plus pi by 2. Put pi by 2, sine pi is 0. Minus pi by 2, you will get minus pi by 2. Then put pi by 3. Sine pi by 3, root 3 by 2, minus pi by 6. And sine minus pi by 3, minus root 3 by 2, plus pi by 6. So which one is the greatest value and which one is the least value? This is the greatest value. Greatest value. Least value is this. The difference, root 3 by 2 minus pi by 6 plus pi by 2. The difference, 6, 3 root 3 minus pi plus 3 pi. Or 3 root 3 plus 2 pi by 6. Hmm. 3 root 3 by 6 will be root 3 by 2 plus pi by 3. That means option C is correct. Next is question number 74. The set of values of x for which 1 plus log x is less than x. So we will take the function, we will take the derivative 1 plus log x minus x. Or you can take this as the function also. 1 plus log x minus x as the function. So the derivative will be 1 by x minus 1. Or 1 minus x by x. So if you make it equal to 0, 1 minus x is 0 or x is 1. That is the turning point. Take x equal to 1 and randomly pick up 0 here. You can't pick up 0. You have to pick up 1 by 2 and 2 here and put it in the derivative. What's the derivative? 1 minus x by x. If you put 1 by 2, 1 by 2 by 1 by 2, f dash is positive. If you pick 2, you'll get negative by positive. So f dash is negative. That means f is increasing, f is decreasing. So what can I say here? F is increasing when x is between 0 and 1. F is decreasing for x greater than 1. So f of x will be less than f of 1. For x greater than 1. That means you have to take the interval 0 to 1, 1 to infinity. Here we are taking greater than 1, 1 to infinity. But 0 to 1, 1 to infinity, f is increasing. That means f of x will be less than f of 1. So 1 plus log of x minus x is less than 1 plus log of 1 minus 1. Log 1 is 0. 1 plus log x minus x is less than 0. Or 1 plus log x is less than x. So option C is correct. 0 to 1 and 1 to infinity. Both we are taking. Because 0 to 1, 1 to infinity. Here I will not write 1 to infinity, but here 1 to infinity, f of x is less than f of 1. 0 to 1 also f of x is less than f of 1. That means 1 plus log x is less than x in the given interval. Okay, next question number 75. The function f of x equal to log x by x is increasing in the interval. I'll put 2 more options here. We'll take f of x equal to log x by x and find the derivative using quotient rule. Log x derivative is 1 by x into x minus log x into x derivative is 1 by x square. So we have 1 minus log x by x square. Increasing means f dash. First you have to take it equal to 0. Log of x equal to 1. X is e. That is what we got. And the other one, bottom x equal to 0. So on the number line, take 0 and e. Randomly pick up numbers. You can't take negative numbers. You can take 1 and 3. In f dash, that is 1 minus log x by x square. X square is anyhow positive. So f dash of 0, not defined. So 0.5. You can use calculator. What is log of 0.5? It's minus 0.6. So this also will become positive. So f dash is positive. Now if you put e, it will become 0. If you put 3, what's log of 3? It's 1.09. So you're getting a negative answer. That means f is increasing and decreasing. Increasing, you can take 0 to 1. They are talking about increasing. But we are not taking 1 at all. 1 is not the point. So 0 to e, we can take. Increasing 0 to e. Zero e. The testing points you are taking is because you can't take 0. You're taking 0.1, something like that, testing point. And then you are taking 3. Something like that. Next, we will consider 76. Rectangles of maximum perimeter, which can be inscribed in a circle of radius a, is the square of the side. So first of all, we will take a circle. Radius is a. Center is origin. So this will be a comma 0. This will be minus a comma 0. We are inscribing a rectangle in the circle. This diagonal is the radius a. This diagonal is the radius a. This is right angle triangle. We'll take length x, width y. So one relation we have is x square plus y square equal to 2a whole square, that is 4a square. Now perimeter of the rectangle is 2x plus 2y, which has to be maximum. Y square you can write 4a square minus x square, y as square root of 4a square minus x square. 2x plus 2 root 4a square minus x square. This is what we have for the perimeter. For maximum, you have to find the derivative of the perimeter. Derivative of the perimeter will be 2 plus 2 into derivative of square root 1 by 2 root 4a square minus x square into derivative of 4a square minus x square is minus 2x, which you set it to 0. So 2 and 2 will cancel. So you can take 2 square root of 4a square minus x square minus 2x equal to 0. Or easy is 4a square minus x square is 0. X is 2a. If x is 2a, you will not get this answer x square plus y square equal to 4a square. But from here, if you put x as 2a, here also we will not get the answer. So suppose if it is a square, x square, y square also will be x square equal to 4a square. 2x square will be 4a square. X square is 2a square. X is root 2a. So option B can be taken. So these all will not help you. This part is not helping you. Only Pythagorean theorem will help you. Next is 77. For the parabola y square equal to 4ax, the ratio of subtangent to the abscissa. Subtangent is y by dy by dx to abscissa. Abscissa means x. This ratio we have to find. So first y square equal to 4ax. 2y dy by dx is 4a. Or dy by dx is 4a by 2y. That is 2a by y. So y by 2a by y is to x. Y square by 2a is to x. Y square is 4ax by 2a. Is to x. X and x will cancel. A and a will cancel. 2 2's. 2 is to 1. That is option B. Next is 78. The subtangent, ordinate and subnormal to the parabola. Y square equal to 4ax. So subtangent means we have to find y by dy by dx. Ordinate means we have to take y. Subnormal means we have to take y into dy by dx. All these. So y square equal to 4ax, finding the derivative, 2y dy by dx equal to 4a. Dy by dx is 2a by y. So y by 2a by y. And then y. And then y into dy by dx is 2a by y. So y square is 4ax by 2a. Then here y. Then here 2a. So a and a cancel, 2 1s, 2 2s. 2x, y, and 2e. Y is square root of 4ax. So these three we have. These three are in GP we can say because b square is AC. B square means square root of 4ax whole square will be a into c, 4ax. So it is in GP, geometric progression. Next is 79. The least possible value of k for which the function f of x is x squared plus kx plus 1 is increasing. The function x squared plus kx plus 1 is increasing. That means the derivative 2x plus k this has to be positive. So k has to be greater than minus 2x on the interval 1 to 2. So for x equal to 1, K will be greater than -2. So least value is -2. Option B. Next we go for is question number 80. F of x, that is 2x cubed plus 9x squared plus lambda x plus 20, is a decreasing function in the largest possible interval -2 to -1. Lambda is equal to, the function is 2x cubed plus 9x squared plus lambda x plus 20. It is decreasing. That means f dash x, that is 6x squared plus 18x plus lambda. Decreasing means this has to be lesser than 0. Suppose we will take 6x squared plus 18x plus lambda equal to 0. So this has roots on the interval -2 to -1. So if you take x as -2 and -1, then product of the roots is c by a, lambda by 6, or lambda is 12. Next, 81. The maximum value, take the function sine power p theta cos power q theta. Find the derivative using chain rule. X power p, x power q. So p, x power p minus 1 theta and cos power q theta plus that is the first one. Second one, what will happen? Sine power p theta will be same. See, we will use chain rule. First, x power p derivative is p, x power p minus 1 theta. But sine theta, we have to multiply the derivative cos theta, cos power q theta. Plus sine power p theta will be same. Something power q, x power q. Q x power q minus 1 theta. And derivative of cos theta, the inner function, is minus sine. Using product rule. You can take sine power p theta common. and cos power q minus 1 theta common. Or if you want, you can take sine power q theta only common. Then what you will have? P by sine theta into cos theta. Here what you will have? Q by cos theta into minus sine theta. Or this is y into P cot theta minus Q tan theta. So for turning points, either y must be 0 or P cot theta minus tan theta. P cot theta minus Q tan theta must be 0. Y means what? Sine power P theta, cos power Q theta should be 0. So theta must be either 0 or pi by 2. And here also, this cannot be 0 at all. Only two values we got. Okay, now because dy by d theta is y into P cot theta minus Q tan theta. D square y by d theta square. What it will be? So doing with this is very difficult. So we have to change the form. Actually, what is dy by d theta? Y into P cot theta minus Q tan theta. But because this is 0, you can write P cot theta equal to Q tan theta. P by tan theta equal to Q tan theta. Or tan square theta is P by Q. Tan theta is root P by root Q. If you draw a right angle triangle, tan theta is root P by root Q. And hypotenuse will be root of P plus Q. So dy by d theta in easy form, you can write y sine power P theta cos power Q theta. P into cot theta root Q by root P minus Q into tan theta root P by root Q. So this will be anyways 0. So dy by d theta will be 0 because this is becoming 0. Now we will take dy by d theta as y into p cot theta minus q tan theta. When you find d square y by d theta square, dy by d theta derivative, p cot theta minus q tan theta is same. Now y is same. Cot theta derivative is minus cosecant square theta minus q tan theta derivative is secant square theta. We already know this will become 0. So y into this we have proved it is 0. Y into minus p cosecant square theta p plus q by p minus q secant square theta p plus q by q. So p will cancel, q will cancel. And then we have 2y minus also minus 2 times p plus q. Anyways, this sum is long one. 81. We'll do it in the next class. Or actually, we have only few questions left. We will end this chapter. We'll go to the next chapter in the next class.